Okay, hi everyone, thank you for your time. So today, myself and Herman will be presenting our joint efforts towards what we like to call the Spiduino. So it's, in essence, we set out to design, build and program an Arduino-controlled, movable, motion-reactive spider with some outdoor capability, right? So the original intent was for it to be commissioned for the amusement and terror of young and old. That's the best way I can describe what this lady's trying to go for.
Actually, we got that right this morning.
There were some small children that we managed to demonstrate for, because my aunt has got a pre-primary school, and they just wanted to touch, and they were like, can't it move, and can't it jump? And almost. Almost. So close. Okay.
Yeah.
So in terms of overall completedness?
Overall completeness. Our initial aim is not met in totality, so we didn't get all the components as we would like to. We completed as much. I'm Afrikaans, so bear with me. Alright. Assembled in wiring and basic coding, we've got that functionality working, so we're quite happy with that.
Yeah, we'll go more into that in a bit more detail in a few minutes' time. But yeah, in essence, the basics is pretty much there. Yeah. So, I don't know, do you want to talk through this a bit more?
Yeah, we'll talk about through this. Weatherproofing, so this is key constraints we got on the spider, weatherproofing. Actually, we got the Junction Box weatherproof. We did not manage to get the spider as weatherproof as we would like to. Initial idea is to put like a small roof just to above it, just not let rain get into the spider. Power, we got the requirements. It's 12 volt. We initially thought it was going to be 24 volt we had to use, but we used a 12 volt power supply at the end. And the size, we didn't take, we had a few improvements on the size. We didn't thought it's going to be looking as big as it is, but I'm quite happy with the big spider. And time was limitations, and the budget.
Yeah. So this seems to be a reoccurring theme, that if you a biggie voorbereiding goes a very long way with this stuff. So having well-defined power requirements, it's important. And we kind of, all of us learned that was important a bit too late. But anyway, now we know. So that's a fantastic thing with using the Arduino microcontroller is it's open source technology. So if we did have questions, there were a bunch of guys online who had done something kind of similar. I did a little bit of research into this beforehand, looking mainly at all the Arduino project hubs you'll go to. That's like your best friend. They've got all the information you need. Then instructable circuits, they had also quite good tutorials. Quite often they had both a video and some sort of an article explaining what was going on, and wiring diagrams. Oh my word, saved my bacon so many times. And then YouTube had a bunch of really fun videos on what was out there. Like over here you can sort of see, I'm not sure, one that's got a couple of the components that we're a bit more familiar with from our tutorial project, like the servos. The servos that we've worked with a bit before, and the ultrasonic transducer. Yeah, so sort of stuff we could sort of recognize what needed to be done there, even if we didn't follow that exactly. It gave us a good idea of how to proceed. Also this guy, it's a very simplistic design, which actually in retrospect would probably have been better. Go for something small, streamlined, just moved around a bit so we would have more time to play around with the coding. But yeah, so this was amazing that there were a bunch of examples that we could sort of bounce ideas off of. So if I had to highlight a few of the key distinctions and similarities between our system book and the other one, if you please click forward. So use the Arduino technology, use some of the open source libraries that were available to us, and would again really help to make sense of the components that we weren't all that comfortable with. So although some of our electronic components are in common with what you find online, for instance, our application of the servo motor is very different to what you'd see online. A lot of the guys, they'd use it to sort of get the thing to walk, which, as cool as that is, nobody was using it to get a dropping distance. Or they were using, nobody was using it for our purposes of wanting to get the legs to curl. I'd never seen that being done in this manner before, so that was something we tried to experiment with. Just the way we wanted it to move was a biggie understood. Right, Anyone?
Okay, so you're some online rock stars.
Yeah.
Liz would be more bombed is actually Liz.
I love these guys for like anything to do with some of the more in-depth sort of coding that I had to get into for like just some of the functions I wanted to try and I later abandoned due to time constraints. This guy had some very fun videos on what not to do. Goodness, all the ways you can get shocked. These guys also brilliant, very clear cuts instructions. So a lot of these guys they do this almost professionally, or you can see that they're in the industry, they know what they're talking about. So it really helps for someone like me who's still very new to all of this and sort of struggles to navigate to see this being done in a precise manner. Oh, also these guys, very, very good for just like initial introduction to Arduino. So first time we took this course, we referred to some of their videos, and it's great with the revamped syllabus to still have these guys in the mix and then a couple of others as well to make it a bit more fun. Yeah.
Okay, so project design, it was like designing the spider. Movements of the spider, we wanted the legs to curl in and out. Like as you guys can see, we wanted the eyes to flash. We also got the mouth flashing red with the eyes. So initial idea was to start off the spider with green eyes with both of the side of the eyes facing, and then when it gets a sense of the sensor it turns red and the mouth goes on, and then the spider would drop in the sequence of the legs moving in and out. So we had to use 4 pair of legs, 2 body parts, get the back and the front, and yeah, then you got like all the jaws and everything at the initialization.
I had no idea that spiders had wings.
No,
They don't. No wings. No wings.
I've seen that.
I needed some sort of an operational definition of what constitutes a spider. So I need those legs.
you may think some spiders can fly, but they actually jump. So,
They jump, yeah.
Can anybody pronounce this word? Because I still can't.
Cephalothorax.
I just called it the thorax. So what was important was that it's got like 2 main body parts, I think, and 8 legs. Yeah. So those were the bits I focused on.
as you can see, this one only has like 7 legs. I dropped it yesterday.
We really weren't going to talk about that.
Damage good.
Wait, where is that?
So,
You didn't tell us.
You should just take off the other one just to even it out.
Okay, right, so we had hand-drawn sketch by Liz. This was actually quite amazing, the sketch here.
So this was, I was trying to keep to being relatively anatomically accurate in that the back, the most leg, and the front most leg are supposed to be the longest, and the middle ones are kind of the shorter, you know? This was very challenging for me. I don't like spiders, so it was an unnerving experience to say the least.
So,
Yeah.
and also a couple of sketches of the components we had to draw.
By now you'd probably be able to recognize that this is the work of a particular art crew, who we all refer back to quite often when it gets to the trickier parts of the mechanical assembly. So yeah.
Richard.
Yeah. In-house mechanic. Yeah.
So you can see the legs and the joints we used on the spider. The legs were, I would say, the most difficult part to do. It took a lot of time as well, but we managed to get that right out.
Yeah, I reckon so.
And SolidWorks.
So yeah, this project turned out to be much more mechanically inclined than what we'd originally set out to do. But it was also great that I got a refresher on how to use the SolidWorks package a bit more, especially with talking to Mano and James, who are going through it, and they're very detail-oriented chaps. So they really helped me, and of course sections with Richard as well. So here's some renderings of the shell. This is for the thorax, and this is for the face. And it's got the, here you can see like the holes for the LEDs. Here's a customized pulley. It's one of these bad boys over here. You can see it's got particular cutouts for the type of wiring we wanted to use. So that was a bit niggly, but yeah. This is one of my earlier versions of the flat perspex base. Yeah, that's going to go underneath the shell. So onto here is where we've mounted all of our, a fair number of our electrical components. Yeah.
I think it's Arduino terminals, and we got the 2 breadboards stuck in there.
Yeah, we'll get to that, yeah. And then a customized bracket for our servo motor, which also needed to go through a few modifications. Yeah.
Okay, this was the wiring diagrams. This is like rough drawings about it. The one you see here is actually the junction box I drew. This was the first idea using battery powered, but after speaking to the lady that actually wanted this, she don't want it battery powered. She wanted like connected to power because she doesn't want to change the battery all the time. So yeah, there was like, and this is Liz's drawing.
Yeah, that's mine. That was yesterday's frantic work with Nick, just trying to figure out how to get the positive and ground buses as they should be. Just those final connections, just so we could do some troubleshooting and some testing. Yeah. As you can see, Herman's is much more streamlined than mine.
There's also some wiring ideas we have.
Oh, yes, okay, so I do actually want to draw a little bit of attention to this because I'm quite chuffed. So this is me just trying to make sense of some of the smaller controlling circuits. Over here we've got a shift register pinouts. It's a bit blurry, but I was just trying to map out like how many inputs we needed, what was important to be lagged and grounded and all of that jazz. Over here is, what is this? Oh, this is the motor driver for the stepper motor. Over here we've got a shift register going to an RGB LED, and then over there we've got some more scribbles. Yeah. So that's just highlighting a couple of the sort of pinout considerations we needed to take into account.
Yeah, the main features. Right, so here we got the mechanical and the electrical part of the spider. On this side you will see the mechanical assembly, like everything. This is the parts we used, and now the electrical part. This is the parts external of it, of the spider, like in the junction box and everything, the PI or sensor, some components of that, and this is like internal parts on the spider itself, like the Arduino and the terminals and everything.
So I used a package called Microsoft Visio, quite an outdated one, just to get a bit of an idea of how to do it. So it's informal, but it shows the thing.
Okay, so here we got bill of materials. So, yeah, junction box were quite expensive. Heavy duty server arm, had to buy that. And yeah, as you look through, you can see so aluminium stand, we bought it too cheap. Like,
yeah, just on the road. I'm gonna miss that.
This is actually a DSTV, like the squirtle stands. we just modified, and yeah, at the end, yeah, we would say the totally cost about $550. I would say it's a bit more of all the things we got, but this is a roughly rough idea. Like taking into consideration all the small stuff.
Yeah,
like,
yeah.
Still need to be good.
Yeah, like okay, so a couple of components were internally sourced, a couple needed to be ordered or bought from, it was like a lot of scratching around. Yeah. So, spent a bit more than we meant to, but okay, yeah. Alright, here are some extracts from our coding. I'm not sure if you want to go through this a bit.
Okay, yeah, so for me, explaining to Liz like how it's done, Afrikaans to English is quite difficult, guys, really. Me working in an Afrikaans environment, it's much harder to explain to somebody in English what I initially thinking and then like what she must do. So I had to write down all this stuff, so I had to sit and write down first what we want to do, why I'm doing this, how I'm doing this, and then she understands. It mostly when we're done with it, and I'll ask her like, do you understand, Liz? And then she'll say like 70%, and then I say, okay, just take a recap back, and then you'll like get.
I see some of the comments are in English and some non comments.
Sorry to leak out the way.
Was it Ningels?
For me, this really cemented how important it was just to document stuff. Like Josh, you were telling me that it's just tricky to read other people's code if they don't have the comments in.
Yeah.
So for me, it was also just for myself, like what did I actually do? Especially when I'm just a little bit sleep deprived. It's good to just have that as rough work, just so I can kind of understand it.
I'm like a doer. She's like commenter. Like she wants to comment everything. I know what to do.
That's a good combination.
Yeah. Right, there's this is also like part of our coding. We actually built like tabs for it, put it in separate ways. Like we didn't get the some parts of this not be able to use like the PR sensor, but we wrote the program and we tested all of it and it works, but we haven't got the time to like get it into the like wiring it up and everything. But yeah, this is some of the codes we used.
Okay, so this is an example of like one of the open source libraries. So that library is like comes, I think, pre-installed on the Arduino IDE, depending on which version you have.
I think that might have been the one that you downloaded, Elis.
It might have, because I got a bit confused at one point. But okay, it's basic stepper driver library, open source. They've gone through a lot of this stuff before, but there were a couple of variables that we needed to tweak to suit our needs. Yeah.
Cool. So, finger extracts. Ooh.
So we started a couple of wiring diagrams on Tinkercad, but I actually found it much better just to write this stuff down in my design notebook, particularly when Herman and I were having work sessions together and then not. Yeah, so unfortunately we don't have a great wiring diagram on the simulator package. We've got a lot of rough work, but we've sort of started it. So you can kind of see the concept that we were going for with having the shift register control a couple of discrete LEDs and then also a couple of the RGBs. Yeah. Oh, and then here's some information that.
So
Yeah. So this was actually from the new syllabus. Then it was fantastic to have just a better understanding of how to navigate all of this open source content through Nick's guidance and like the new layouts, and just like knowing, okay, what do I need to know to get the thing to work. So here in terms of like the mechanical components, I know Richard tries to explain this to me as well, and it helps to have a good diagram and sometimes to see them as moving parts. Other times just trying to figure out like that's, yeah. So for particular RGBs, I think the long leg can either be a common cathode or anode. So that was quite an important distinction that we had to test in order to figure it out a lot of the time. And then here would be some examples of how to write the different micro-step resolutions to the stepper motor driver. Yeah. So it was actually nice to work with relatively straightforward outputs, even though despite them being straightforward, it was still a challenge to understand, but carrying on.
Alright, so your project design, program planning.
Right, so a huge takeaway.
Yeah, so your
A huge takeaway was like how important it is to look at the data sheet when you want to figure out what you need to do. And that was again a big thing that kept coming back from discussions with Nick. So I put them all in a folder on a shared Google Drive so we could have a look if we needed to, just to figure out like what did we need to put to not blow the thing.
Yeah, how do we need to wire it and everything. It's quite important really, guys, when you're working with stuff, to use your data sheets, information about stuff. Just don't go and wire it, you will blow or something, trust me. Right, project testing, oh my word, and yeah, this was one of our difficult parts of the assembly of anything. Mechanically, the leg assembly, you guys know how long I struggled like assembling the fish gut and everything to the servo motor. Yeah, it was like crazy. Electrical, I would say, is the stepper motor. So we didn't manage to get that right. And the PIR connection we didn't do, but we tested most of the parts and it worked fine. Modifications, Liz?
Oh right, so like Herman was saying, the legs assembly, trying to get those legs to curl the way we want to do, actually turned out to be a lot more complicated than we originally thought. So it required a couple of mechanical modifications. So a couple of the 3D parts I had to customize. So like this over here, I want to draw your attention to a little bit later, although I might have already gone past it. Yeah, but it's got like, I think it's really interesting. So
Find the slide 4.
it's like, it's got a hole that goes there, cut out that goes there, and that's so that we didn't have to drill at an angle into our small perspex pieces.
We'll see like just why we don't drill.
Yeah.
And yeah, servo motor, we had problems with the servo motor, we had to get a bigger one because the mini, right? It's the micro. The micro didn't have enough strength to pull all the legs. So we had to do that. Initially we thought we were going to use a 24-hour supply like I mentioned, but we managed to get a 12-volt working for all of it. So that was like one of the breakthroughs. Alright, improvements. Yeah, so Liz actually mentioned this, and I think this is a big part of it. Adding counterweight to the pulleys. Liz, if you can explain. I think you'll explain it better in English.
Where's the counterweight?
So, good question. Thank you for
It's
highlighting
the
that.
proposed.
Yeah. So the proposed counterweight placement would be it's on the side pulleys. So Richard, so yeah, there's a bit of deliberation as to whether it would be better to put it at the back or the front. I think, yeah.
Well, the back probably.
Also
Yeah.
managed to test the legs and giving it a bit more weight.
Yeah. So this is the thing, like trying to figure out what to do first. So we've attached the 2 front legs to the back pulley.
Yeah,
Yeah.
going up
Yeah. And the weight. Okay. So then the counterweights would then need to be
on the front, yeah.
on the front, yeah. Which, after discussing with Richard, we realised it would actually have been maybe a bit better to put them, like to swap that whole thing around. But, you know, you live and you learn, so that'll be something that we want to just investigate going forward.
But we got more flexibility out of the legs using the biggest servo motor though. That is quite good. And electrical, yeah, the PIR sensor, and just neatening the code and everything.
So here is an electronic component that I really wanted to use for an additional functionality for the Spider, but didn't end up getting to it, unfortunately, after looking into it and realizing it wasn't quite what we needed, and we'd already ordered it by that point, so that was my bad. It's a little audio module, so it's able, very similar to Josh's thing, that it's able to record and then play back an audio, but not quite as sophisticated.
No, so what we wanted to do is...
Elizabeth?
Yeah? Okay, so carrying on. Yeah.
Technical challenges and success and difficulties, like attaching the legs to the pulleys, wiring between the box and the Uno would be the most technical challenges, and the coding was the lack.
But we had some breakthroughs.
Technical breakthroughs, yeah, we actually got the wooden stand, successful assembly of the Spider itself, and the code.
Yeah. So the ability to be able to write simultaneous functions to different outputs that actually work together, that was, to me, that was a big breakthrough, because I couldn't do that before. Right, so looking back on the project, it was absolutely a team effort, by all accounts. So there were particular things where Herman was more strong, so he took the lead in those, he was more knowledgeable, and then there were certain things that I sort of had a bit of a better idea of how to approach, or I just had the more time to focus on it. So when it came to like planning of the mechanical components, I took the lead primarily, but a lot of the conceptualization work I have to thank Richard for, absolutely.
Yeah.
And then also James and Armando, just the sessions that we had just talking together really helped me get my head together. When it came to actually building, that would be then when Herman sort of took over a bit more, being a bit more confident on how to go about that. But I did help, and I did use some power tools, which was a lot of fun. And I did help with the assembly of this whole structure, so that was also really cool. Again, under keen supervision. I don't know why everyone gets so nervous when I start using power tools. Anyway, then when it comes to the electrical design and build, Herman again took the lead on that, mainly, again with assistance. Some on-roll shout-outs again being James, and Nick, just of sort of understanding things, and then,
Okay, we're gonna but skip through this because our time is...
Okay, programming a bit more shared.
Yeah, so there's the programming side of it, like the build, the test, and the troubleshoot. That's one of our biggest time we spend on it, like building it, testing it, finding a problem. Okay guys, so real world.
Yeah, so the intent is for this to be commissioned in Swansea for this lady, Celeste. She's had this fairy sanctuary, I'm not sure if anybody's heard of it, you can find it online. Really, really cool space, very artistic. This is kind of the area that she'd want it to be in, so quite open, relatively near some sort of shrubbery and structures, but this is why we needed to have its own fixed structure, because you can't just stick it against a tree, and we want it to be able to be movable in case she wants to move it as the park progresses. So that's why outdoors capability was quite important. But in addition to that, I also thought it could be you know, if us moving up there, it could be quite a cool like educational tool, especially with the bare bones look of it, that people can see, you know, how to make something like this using this technology, and that the college is able to provide, you know, the resources and the knowledge to do that. And on a more small scale, you know, maybe just getting people a bit more comfortable with spiders, especially myself. So, you know, fighting arachnophobia one tiny fur at a time.
One big spider at a time.
Can
yeah.
you-
Yeah.
Can you
Not quite
demo?
as cute as Lucas.
Can you demonstrate it quickly?
Yes, yes.
Because we're running time. It's
we
really.
have
video.
videos.
Just in case the demo doesn't work.
Alright, so lessons learned. Yeah, you can just read through this. This lessons I have positive habits, negative habits of me. Well,
No,
positive
we're not going to rush
habits.
through that. This is important.
Okay, positive habits of me is around like teaching Liz well spoken, like getting the chance, like explaining myself more to her, like what needs to be done. Task oriented focus, like we spend much hours working on this task, I must say, and like consistent work ethic. Negative is distracted by commitments of my work and everything, so as you guys know, couldn't attend class on Tuesdays and Thursdays and to work. Yeah. Tend to rush my work. Liz doesn't agree with me with this, but I do, because I know I rush work without thinking it through. Like I do something and then thinking about it, I had to plan it and then do it.
So for both of us, it was definitely a lesson in just trying to be a bit more systematic with our approach. Yeah.
Yeah, so here's my marks. We managed to get ourselves. Time management 6, PVT 8 out of 10, programming 8 out of 10, problem solving 9. Yeah, lessons I learned. Yeah, it's like keep practicing my AutoCAD. That's really terrible. Like, Richard, you must please help me with that.
AutoCAD. I didn't even teach AutoCAD.
AutoCAD.
It's like
Oh,
Tinkercad,
solid.
but in some
I
ways
did
better.
AutoCAD, yeah.
Yeah, did you do AutoCAD? Yeah.
Yeah.
Keep practicing my AutoCAD.
Why do you want AutoCAD?
Hmm?
Or why do you need AutoCAD?
Because
We
it's a
had to do the wiring diagram on AutoCAD.
Well, it's schematics. We're just trying to find like a nice
Why don't
chunk.
you use
Been using
the other one that you guys been using? What's it
Fritzing.
called? Yeah, Fritzy.
AutoCAD is massive.
Oh, really?
No, no, like,
It looks much neater as well.
Josh, you do an excellent job on fritzing, but I struggle a bit, like especially if I'm not too sure and I want to change a pin. And like what you told me, like you need to, you know, there's just particular user interface things, and you've got to not very smart.
Guys would really have a schedule. We're
Okay,
going to be
let's
late
keep
for
going.
our.
So I try to pay attention to detail, and I try to learn. Feel like I didn't ask enough questions, and I tended to overcomplicate things. So it was nice to have a second head to go back to. Yeah. Go. Okay, didn't do great. Would like to do better. Feel like I was a bit slow. Yeah. Carrying on. Gonna keep trying and keep tinkering. I think that's the biggest takeaway I've gotten from this. Is to take things away. Okay. Here's some slideshows of our stuff.
Okay, there you can see why we don't, we need to drill, like, we made it, because there's a drill bit stuck in one of our legs.
Yeah, dude, our spiders are cool.
Hopefully it's the one that broke off. And this is like some of our components and evidence. This is like how we managed to test it.
That looks scary.
Wanted to, yeah, cover the spider with this. Didn't manage to get the time to do that.
Yeah. So that's more of an aesthetic thing. Yeah.
And this is some of the
Oh, this is
components.
important. Yes. Go.
This is some of our components we used.
Yeah.
Yeah, applying it to the rack. Just working hard at night. And yeah, the videos. Liz.
Yeah.
You're good.
Oh, you're right there.
Okay, so yeah, like I said, we managed to get the LEDs and the server monitor up and running, not the stepper and the PRs and so.
No. You need it down like that.
Right.
Yeah, you can play.
Yeah, it's gonna be rough, but it's gonna be there. Okay. So console connection straight in, just in case it's being funny. So you see the LEDs do a thing. And the legs. And release.
Can I say like a singing band?
Yeah.
But yeah, the eyes turn green. At the beginning the eyes are green. When the loop starts, the eyes turn red, the mouth goes on, and the side eyes blinks. And then after a while the legs will cramp in, and then we'll release again.
Okay, this was a test
When will it
program.
drop?
Oh, they're under.
Yeah.
The drop, we didn't manage to get the...
Oh no,
step-
but when it's when you have it right. When
Oh
will
yeah, it will.
As soon
the
as you
eyes-
pass
okay.
the
like
sensor.
what we wanted to do was the spiders like sitting as it is. It would be a top with green eyes facing and the side eyes on. When motion is picked up by the PR sensor, the spider would begin drop, the eyes would turn red, the mouth would go on,
I'm gonna play it again.
pulling it down,
Alright.
and then when it gets into the middle, the legs would have cramped up, going down, and then release.
Are the legs or the joints like spring loaded?
No, that's
Elasticated.
elasticated. So that was a
Okay, well it's still spring.
Yeah.
yeah,
Technically,
yeah. It's O-ring elastic.
Okay, very cool.
Yeah. So that was just the thing, because we had to cut it, then trying to then attach it again was the
So
challenge.
yeah, guys, thank you for listening and questions.
Oh, the other thing is obviously when the spider drops down, you can hear the servo motors
It's
obviously
kind
struggling.
of creepy as a.
Oh yeah,
That's
I
why,
guess.
yeah,
I guess, yeah. I don't know, maybe you could do the same thing that remember I did to my
Initially,
sun
we
following thing, because you know they're under tension the whole
Oh,
time,
yeah,
so you can
yeah.
switch it off with the
initially we did write it to from 0 to 90.
Yeah.
90 degrees, and it didn't make a sound, but the legs didn't cramp us as much as we wanted to, so we wrote it to 100, right?
180 then 120.
But what I'm
Okay.
saying is that their holding torque is pretty good. So
Yeah.
even if you switch them off, it will stay in that
Yeah.
position.
It's already exciting.
Yeah, I'm just, yeah.